Alright, so as you can see, we're on lesson 4 in this beautiful handwriting of the International University of Management Quantitative Methods 1 course. So in this lesson, we're looking at measures of dispersion. The previous lesson was measures of central tendency. Now we're looking at measures of dispersion. So what did measures of central tendency tell us? Well, measures of central tendency, that told us something like, if you have your graph, what is sort of the middle value? Mode, median, mean, what's in the middle of your data? Now, measures of dispersion will tell us, on average, how far is everything away from the center. So if we look at it like on a scatter plot, if we draw these are our values, then we draw a line of best fit. The measure of central tendency that just tells us basically what this line is. The measure of dispersion will tell us how far are these values away on average from this line. How wide is the data spread? All right. So if we look at it, so in this graph we see it's pretty close, small dispersion. But if we have something like that, that's a quite wide dispersion. So smaller dispersion is better in general, makes predictability, and to be able to say what will happen if we do this, that makes that a lot easier to do. Okay, measures of dispersion, we'll look at a couple today. Now, let's see, what do they say in the book? The measure of central tendency serve to locate the center of the distribution, like we saw over here, but they do not reveal how items are spread out on either side of the center. So is it like this is a small spread, right? There's the center and everything else falls sort of in here and it's pretty even. We could also have something like that. So there you have your center, but it's spread out pretty wide from the center. Or we could have something like this. So central tendency is right about there, but there's a lot more values on that side than on this side, that type of thing. Right. Okay. The characteristic of a frequency distribution is commonly referred to as a dispersion. So what it looks like. This dispersion will tell us what type of shape our curve has. The degree of, where are we now? In a series, all items are not equal. There's a difference or variation among the values, like obviously every number is not a 5 or a 6. There could be a 3 or a -5 or 123. The degree of variation is evaluated by various means or measures of dispersion. Small dispersion has a high uniformity of the items, while large dispersion indicates less uniformity. Consider the following two students, student 1 and student 2. Now these are supposedly marks they scored in tests. So test 1, test 2, 3, 4, and 5. And we can see if we just look at the data, what's your gut instinct? All these values look fairly close together, so do these, except for this outlier, right? Now if we compare these values, they average, they've both got a total of 345, we can read that in the bottom here, and the average of both is 69, the mean. So it looks pretty similar, but we can say student 2 has one thing that stands out. So student 2, his or her, measures of dispersion will be wider, right? Because not everything is very close together like in this student. So in this student, because it has this lower dispersion, we could more readily guess what his score in the next test will be. Whereas this student, we know mostly he scored a couple of tests over there, but then a 25 and a 65 a little bit further away. Even this number is not that close to the others, right? All of these ones are pretty close. So good uniformity, not such good uniformity. So this is a small dispersion, large dispersion. Now let's look at a couple of things we can do for dispersion. So range. Okay, range, that's straightforward, just the largest value minus the smallest value. So if we go back to this example, what's the range here for student 1? The range for student 1 is largest value, what is that, 75, smallest value, 65. So the range is 10, small dispersion. Student 2, highest value 90, smallest value 25, that's a 65 range. So we can see already in the first case, student 1 has a better dispersion, a smaller one. This has a worse dispersion. Alright, but that's a straightforward one. Largest value minus smallest value, no tricks there. The mean deviation. Okay, so the mean deviation, we'll do a couple of examples on this. The mean deviation is how far the values in a given set are spread from the mean. So we looked at that briefly when we just looked at this scatter plot. This will have a large mean deviation. right? Because these values are quite far from the mean. That's the idea. If all the values were like here, it'll be a small mean deviation because all the values are pretty close to that, to the mean. Okay, and here's our formula. So we take the absolute value of each value minus the mean, and we sum that and divide it by the total number of things. So we can say it sort of has a lot, it looks a lot like the mean, but we're actually using the actual mean in the equation. And for group data, we'll use this when there's frequencies involved. All right, let's have a look at an example to get some concrete things going here. So calculate the mean deviation for the following data of marks obtained by 40 students in a test. All right, so first we see in the formula here, we need to find the x bar. And remember, what is x bar? X bar, that is your mean. So we have to obtain the mean from here. So how will we find the mean? Well, we add everything together divided by how many things there are. So we know n, the number of things, is 40 students. Right, so if we add all of this up, we'll get 40. Now we see there's two 20s, four 30s. So two 20s gives us 40, plus 4 30s is 120, 8 40s is 320, 10 50s is 500, 8 60s is 480, 4 70s, that's 280, 2 80s is 160, 190, and 100. So we add all of that up and divide it by the 40 students. Okay, I'm going to use calculator for this one, I think. Calculator. All right. So what we have 40 plus 120 plus 320, 500, 480, 280, 160, 90, and 100. All of that divided by the 40 students, and we get a mark of 52.25. So 52.25. So that's our x bar, is 52.25. Very important. All right. Now we're going to say the xi. Xi stands for the individual x value, for each individual score. So we're going to say the xi, so this is x1, x2, x3, x4, etc. So xi, that's just all these numbers. We're going to say xi minus the x bar. So xi, so it's 20 minus 52.25. So 20 minus 52.25, negative 32.25. So negative 32.25. Okay, we're just going to repeat that for each case. So that'll be 30 minus that. So negative 22.25. Negative 22.25. 40 minus that, negative 12.25. 10 minus 52.25, 50 minus 52.25. That's going to be negative 2.25. 60 minus that, it's going to be, oh, let's quickly check. What is 60 minus 52.25? That should be 7.75. Nice. Okay, so that's 7.75. 70 minus that is 17.75. 80 minus that is 27.75. And 90 minus that, 37.75. And 100 minus that is 47.75. All right, so that's the xi minus x bar. Now we take the absolute value. So what does an absolute value do? It just changes everything to a positive, right? So that's just positive 32.25, positive 22.25, etc. I'm just going to finish writing this one out. For the next example, I won't do all of this over again. 7.75, 17.75, 27.75, 37.75, and 47.75. All right, and now we say the frequency, the Fi, so the frequency of each mark multiplied by this column. Okay, so we're going to write this in the calculator. Okay, so 2 times 32.25, 64.5. 64.5. Then we get 4 times 22.25, 89. 89. And then we get 8 times 12.25, 98. and we keep going with all of this. So let me just complete all of this. I know it takes a little bit of time. 2.25 times the 10, that's 22.5. Then we've got 8 times the 7.75. Ooh, almost typed something wrong. 62. And then 4 times 17.75. So 4 times 17.75, 71. Then we've got 2 times 27.75. 2 times 27.75, 55.5. And 2 more to go. 1 times 37.75, so that's just 37.75. And 1 times 47.75. Okay, so we can see this is quite tedious, but it's nice to be able to understand where all these things come from. Later on, you will be able to just put in the values, like make this table, and Excel or whatever spreadsheet can do this for you, or any other specific statistics programs if you have any of those. Okay, now we're going to add all these together, like the sum of the fi times xi minus x bar. That's this column. We're going to sum this column. So 64.5 plus 89 plus 98 plus 22.5 plus 62 plus, ooh, what did I do? I did something wrong there. Start over. 64.5 plus 89 plus 98 plus 22.5 plus 62, 71, 55.5, where are we now? 37.75 and 47.75. 548. 548. All right. And then we said that value, that answer we get, we divide it by n, which is 40. So we'll find our mean deviation. So let's just write this: mean deviation. Oh, I can't really write tonight. Equals 548 divided by 40. And that's our final piece of the calculation. Divided by 40, we get 13.7. 13.7. So there is our mean deviation. Okay, so you can see it's a bit of a tedious task, but it's good. Like I said, I think it is really good to be able to do this. And then you'll get a better understanding of what's happening behind the scenes when you just let a computer or a calculator do all this for you. Alright, the data below represents the earnings of 50 workers in the factory. We'll do exactly the same thing as we did over here. Right? So I'm going to skip that one. Over here, calculate the mean deviation from the mean of the following distribution. So I've already added in a couple of columns and rows to preempt the time it takes to just draw them. And let's see what we can figure out here. Let's do this one in red. Okay, so we're going to do the same thing. We have to find our xi minus x bar. We're going to find xi minus x bar, the absolute value of that. And then we're going to say the frequency, fi, times xi minus x bar. All right. And actually, I'm going to move all of this down. We need something else as well. We need something more. In this case, we also need, we see there's no individual values here. So what will our xi be in this case? Our xi will be the midpoint of these. So how do we find the midpoint? Again, we can say the lower limit plus the upper limit of the class divided by 2. So that's what we'll have here. Find the midpoint of each class. 45, 55, 65, 75, 85, and 95. Great. Now we need to calculate the mean. Okay, so how do we do the mean? Well, for the mean, we said for group data, we take the xi times, or the midpoint times the frequency. So the midpoint times the frequency, we'll do this in, just at the bottom here, let's do that in a different color. So 4 times 25 is 100. 6 times 35 was 210. 8 times 45, 8 times 40 is 320. 8 times 5 is 40. 320 plus 40 is 360. 12 times 5. sorry. I'm having a bit of a sneeze here. Okay, 12 times 55 660. 660. 7 times 65. 7 times 60 is 420. 7 times 5 is 35. So 420 plus 35 is 455. 6 times 70 is 420. 6 times 5 is 30. So 420 plus 30 is 450. 4 times 80 is 320. 4 times 5 is 20. 320 plus 20 is 340. 3 times 95. So 3 times 90 is 270. And 3 times 5 is 15. So that's 285. Okay, just a bit of mental arithmetic practice. That's always good for the brain as a warm-up. Now we have to add all of these together. Let's do a column here for that. And I'm going to do this one on the calculator this time. So 100 plus 210 plus 360 plus 660 plus 455 plus 450 plus 340 plus 285. So 2860. 2860. Okay. Then we divide the 2860. 2860. That'll be x bar mean equals 2860 divided by the number of things, number of employees. So that'll be this total here. So 4 plus 6, 10, 18, 30, 37, 43, 47, 50. Okay, so divide that by 50 and that will give us our mean. Divide that by 50, we get 57.2. 57.2. All right. Now let's get back to our red column, our red table. So now we have to do 25. So xi minus x bar. X bar is 57.2. So 25 minus 57.2. 25 minus 57.2. That's negative 32.2. So negative 32.2. And we'll see there will be a pattern. Because now we're going to do 35. 35 minus negative 50 minus 57.2 is negative 22.2. We see we're just decreasing by 10 each time because this is increasing by 10 each time. So negative 12.2, then negative 2.2, and now for the next one, just make sure you don't make a mistake by just keeping on going once it starts, once the xi gets bigger than the x bar. So we're going to do 65 minus 57.2, and we see that's going to be 7.8. 7.8. Okay, now we can, let's maybe just do one more to see the pattern again. So it's going to be 75, see, 75 minus 57.2, that gives us 17.8. So you see this trend now continues again on the other side, adding 10 each time. So this will be 27.8, and this will be 37.8. And then we just do the absolute value of those, so that's just the positive version of each one. So if there's a negative, you just get rid of the negative. And that is pretty much the most important part here, 7.8. Because if you don't do that, there's a chance you'll get an answer of 0, which is not what we want. That doesn't give us the full picture. That's why we're taking the absolute value. And the reason for that is, maybe that might be good to explain. If that's our line of central tendency, we've got some values here. So if we take that distance, that distance, that distance, that distance, that distance. Now if we add all of them, let's do another one here. If we add all of them up, so this distance will be a positive value. This will be a negative. But if we add all of them up, we'll also probably be 0. That's like 2, negative 2, 3, negative 3, and let's say 1 and negative 1. If we add all of that up, we'll get 0. But if we absolute value them, then this will count as positive versions, right? So 2, 3, and 1, that's 6. Another 2, 3, and 1, that gives us 12. So we'll see this is actually why we do the absolute value, so we don't get a 0, which will be meaningless. All right, we're almost at the last step. Now we multiply the frequency by the previous row. So for this, I'm going to use a calculator. 4 times 32.2 gives us 128.8. 128.8. Next, we've got 6 as a frequency there, times 22.2. So 6 times 22.2, 133.2. 133.2. Next up, we've got 8 times 12.2. 8 times 12.2, 97.6. 97.6. Next up, 12 times 2.2. 12 times 2.2, 26.4. 26.4. Then we've got 7 times 7.8. 7 times oopsie, not minus, times 7.8, that's 54.6. 54.6, so you can see this takes quite a bit of time to do these things. The only good thing is it's not difficult, it's pretty easy. So that helps a lot. 106.8, 106.8, and then 2 more to go. 4 times 27.8, 111.2, 111.2, and the last one is 3 times 37.8, which is 113.4. 113.4. Great, almost done. Now we have to add all this up, sum the fi times xi minus x bar. So that plus 111.2, to type it correctly, plus 106.8, plus 54.6, plus 26.4, plus 97.6, plus 133.2, and 128.8. So we get 772. 772. And we said that value we're going to divide by n, because our mean deviation, what's the formula for mean deviation? Mean deviation is the sum, ooh, that's an ugly sum, let me just write that again. The sum of our fi times the absolute value of xi minus x bar all over n. Okay, so this top part, the sum we found was 772 and the n was 50. All we do is we divide that answer by 50. 15.44, and that is it. 15.44. So you see there's not too much to it except for a lot of time, but the actual work is pretty easy. Okay, couple more to go. So that was mean deviation. We've already looked at range. Now we can still get variance, and then we'll still get standard deviation. Standard deviation and coefficient of variation. These two will be very quick. This is all we need to know for them. So for variance, we'll still have a bit of work to do. All right, variance. So variance, again, you can see it follows a similar kind of pattern. We have an xi, we've got the x bar, we do something to that answer, and we divide it by n again. All right, so here I've already written up a table, just giving these values. So this is the daily sale of sugar in a certain grocery shop. On Monday, that much, Tuesday, 120, etc. And I've already put that in a column. Now let's see what we can do from here. So maybe let's just write down this formula so we can see it as we're working. So the formula for variation, so that's the variance, sigma squared. That's a small letter s in Greek, by the way. Capital letter S in Greek, small letter s. All right, so sigma squared equals, and then we're going to do the sum of the frequencies fi multiplied by the individual value minus the average or the mean squared, and we're going to divide that by n. Okay, so we see that's why we need this column here, xi minus x bar. But to find, we first need x bar, right? We need x bar before we can continue. So let's find x bar. Let's do this in over here. So to find x bar, again, how do we find an average, the mean? Just add everything together divided by how many things there are. So this one I'm not even going to write down, I'm just going to type everything into the calculator. So we add everything, 75, 120, 12, 50, 70.5, and 140.5. And we're going to divide that by 1, 2, 3, 4, 5, 6 days. So we get 78. 78. Okay, and the great thing is they already told us that, but it's nice to just work it out and see that it is exactly the same. All right, so now we're going to say xi minus x bar, so 75 minus 78, that's negative 3. 120 minus 78, what is that, 42. Maybe I should just use a calculator so I don't teach you the wrong values here. So 120 minus 78, not times, minus 78, 42. Okay, so that is 42. Then 12 minus 78, 12 minus 78, negative 66. 50 minus 78, that's going to be negative 28, 70.5 minus 78, negative 7.5, so negative 7.5, and the last one here is 140.5, 140.5 minus 78, and that's 62.5, 62.5. Alright, so now we're going to take this value and square it. Alright, so negative 3 times negative 3, 9. 42 squared. What is that? 42 times 42. 1764. Okay, 1764. Negative 66 squared. So, and we can put the brackets just to show you negative 66 squared, that we don't need to care about the negative because negative will always fall away if we square it. So 4356. 4356. Negative 28 squared. Okay, so let's just change this to a 28. 784. That's 784. Then we do the same with negative 7.5. 7.5. 56.25. And one more to go. That is a 62.5. Okay, 62.5. 3906.25. 3906.25. And what do we do now? Well, we add everything up, add it together again. So plus 56.25 plus 784 plus 4356 plus 1764 plus 9. All of that. So that's 10876.5. 10876.5. So that is the sum of these ones. But do we want the sum of this one? No, we don't actually, right? That's not in the equation. What we do want is the Fi. Well, let's just go back to the top to see. The Fi, the frequency, how many 75s were there? Well, just one, right? One of each of these. So if we multiply it by 1, we'll just get the same value. So this is actually what we want. And in the equation here, we can see if it doesn't have a frequency, if the frequency is just 1, we just use this part. If it had a frequency, we sum with the frequency part. And that'll be maybe the last one we do today. Maybe we won't even do this one today. Okay, anyway, so then we have that. And in this case, we can ignore this because that is just 1. So we multiply everything by 1, it doesn't change. And then we divide it by n. How many days were there? 1, 2, 3, 4, 5, 6. So we divide that by 6, and that'll be our answer. So divide by 6, 1812.75. 1812.75. And there we go. That is our variance. All right. So if we had something that had a frequency column as well. So let's say we didn't have days, we just had the number of times. Let's say we ignored the days. And how many times did we sell 75 things? 1 time. How many times did we sell 120? Let's say that was 10. And this was 3, 5, 7, and 21. Then we would have to go 1 times 9 is 9. 10 times that is 17640. And then we'd have to add this column divided by 6. Well, it won't be divided by 6, it will be divided by this column. Right, the sum of this column. We just write a sum sign there. So that'll be the only difference. So it'll just be 1 extra column of work. And this is the case, not over here, no. This is exactly the same as the previous one. I'm just going to start it, I'm not going to finish this one. So I'm just going to work out for us x bar, and then just start filling this in, but I won't complete this. You can do this for homework, and let me know what you got as an answer in the comments below. Okay, so let's add all of this up. So I'm going to use a calculator for this again. So we've got 10, 12, 15, 12, 16, 20, 13, 17, 15, and 10. So that's 140. And how many things are there? 1, 2, 3. Well, tell us it's 10, right? So we can just divide that by 10. So 14. So x bar is 14. So again, what we'll need to do here is just 10 minus 14. That'll be negative 4. 12 minus 14, negative 2. 15 minus 14, 12 minus 14, 16 minus 14. 20 minus 14, 13 minus 14, 17 minus 14, 15 minus 14, and 10 minus 14. And then we square each of these. So 16, 4, 1, 4, 4, 36, 1, 9, 1, 16. And now that we've squared all of them, this is what we add up together. So we add all of this up, sum this, and divide that answer by how many things there are, which is 10. Okay, I'm not going to do all of that, but you get the idea. And the last couple of things we need to look at. So this is a variance for group data. Again, I'm not going to do this one. I think I've explained the idea for group data. The xi will just be the midpoint over here. Just quickly again, how do we find the midpoint? Take lower bound plus upper bound divided by 2, which will give us 31 plus 35 in this case will be 66 over 2, and that gives us 33. So the xi here will be 33. So you just find the midpoint for each of these things. So this will be 38 for that one, 43 for this one, 48. So it's actually a nice pattern. It just keeps going in this way. 53, 58, 63, 68. So there's the xi's. Then you go xi minus x bar, and again x bar, we did that already in the previous lesson. How do you calculate the mean of group data? You find your x bar, then you just say the xi minus x bar. You write that answer. If x bar, let's say this was something like 41, then you say 33 minus 41 and write that answer in, which will be negative 8. 38 minus 41, negative 3, etc. You write this in. You square each of these answers, so negative 8 squared would be 64, negative 3 squared would be 9. Then you multiply this answer by the frequency. In this case, this is the frequency, so 2 times 64 would be 128, 3 times 9 would be 27, and you fill all of this in, sum this column, and divide it by how many things there are. So in this case, they tell us it's 50. If they didn't tell us, we'd have to count all of this up and see that it adds to 50. Great, and that is again your not standard deviation, your variance. Now, what is the standard deviation? So we saw variance was sigma squared, right? So that is the sum of the xi minus x bar squared over n. Now all that the standard deviation is, that's just sigma. So what does that mean? Sigma is just the square root of the variance. So if we found our variance to be let's say the variance was 16. Then what is the standard deviation? Well, it's the square root of 16, so that is 4. So standard deviation is just the square root of the variance. Good. And the final thing for today, the coefficient of variation. So here, this formula, also pretty simple. It uses the standard deviation, which you already have, and the x bar, the mean. Coefficient of variation is a measure of relative variability. It is the ratio of the standard deviation to the mean. For example, the expression of standard deviation is 15% of the mean is a CV, a coefficient of variation. So coefficient of variation is just equal to your standard deviation divided by your mean times 100. Right, so let's use this again. Let's say we had our variance was 16. So if our variance was 16, whoa, that's a 16. Then our standard deviation would be 4, the square root of the variance. Okay, so that'll be 4. And let's say our x bar, our mean, was 25. Okay, so let's make it 24 just for a nicer number. Then we'd say that over 24 times 100. So what is 4 over 24 times 100? Well, 4 over 24 is the same as 1 over 6 multiplied by 100, and that'll give you something like 16.67 if we round it off %. That's the coefficient of variation. Okay, that is it for this video. Next up, we'll look at measures of locations. That'll be quartiles, deciles, percentiles, and you'll see those are pretty straightforward. It just works the same as the median. There we get median. Works the same as that idea. Okay, that is it for this lesson, and then I'll see you again for the next lesson shortly.